All right, week 36, part 1. We are reviewing for the final. So you have seen all this information before. Let's work through some examples. Question number 1 just tells us find the nth term. So they don't specify a certain number, so that means we're supposed to come up with a formula involving n to tell us the value of the term. For example, this is the fourth term, and the value is n. 8, and this is the third term, and the value is 5, etc. So first you recognize the pattern, and you see how we add 3 every time. Therefore, it is arithmetic, and the common difference is 3. So if we look over here, we figured out the pattern. It is arithmetic. The common difference is 3. This is the formula you are given. It is for the explicit formula when it's arithmetic. So D is the common difference, N is the term number, A sub 1 is the value of the first term. So we just plug in and we get this. This would be acceptable. If you distribute 3n minus 3, you end up with this, and this is kind of easier to work with. Both are correct. Number 2. Find the sum. So a little review of the sigma notation. This means this is our explicit formula. We start with k equals 0, and we plug in k equals 0, k equals 1, k equals 2, k equals 3, and k equals 4. That's what we end with. All those numbers are then added together. So I solve this two ways. If there are a few number of terms, you can do this. So I plugged in, and these are the values of the terms, so we would be adding these together. If there are lots of terms, such as if k goes up to 100, then what you probably want to do is figure out, let's see, what did I do? Oh, this is geometric, so don't have to know the last term. So here's our formula for the sum of a geometric sequence of numbers. We have the value of the first term, common ratio. We would need to know the number of terms. So if it starts at 0, going up to 4, that would be a 5. Let's see. So I have common ratio is 3. That's the thing we multiply by every time. Times 3, times 3, times 3, times 3. And I substitute in, plug this in correctly, and I get 242 as the sum. So this is also these guys added up. So it works both ways. If you have only a couple terms, this is probably easier, but if you have lots, this will be easier. Okay, you'd be using this one if it were arithmetic. So for number 3, we're given some sequence of numbers here. We don't know what's in between. We know it goes 1, 4, 7, dot, 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 all the way up to 307, and it says please find the sum. So again, I wasn't very creative when I made up all these examples, but the common difference is 3. And if we're going to find the sum of the numbers, we are using this. We have the number of terms, the first term, the last term, and well, it's the average of the first and last term. So I definitely knew that the last term was 307, but this I had to calculate how many terms there are. So we calculate how many terms there are by using an explicit formula. So based on value of the first term, n minus 1, and the common difference, just like we did in example 1, we can write an explicit formula for the value of any term, and we know that 307 would go in here, and we'd solve for n, and we'd get whatever we got. What was it, 103? Okay. So solving for 103, that means there are 103 terms. Then you can plug it in and end up with the sum of all of those terms, which is this. So if you were to sit there for quite a while on your calculator and just add them up, you'd get that same thing. Okay. 4 has a bunch of words, and what it says is the second term of a geometric sequence is 3, and the fourth term is 27 over 16. What is the first term? So I like drawing out these spaces. We know that the second term is 3, third, and then fourth is 27 over 16. So because it's geometric, I have times r, times r, times r, times r, just to get me thinking about this. So right here, with this information, we know that 3 times r equals 27 over 16. So this is that in equation form. R times r is r squared. So you just use your algebra skills a bit. And we would divide both sides by 3. We'd take the square root, and then we'd get the common ratio. So we know that this times 3/4 is this times 3/4 is this times 3/4 is this, and so on. So this right here is me putting this situation into equation form. A times 3/4 equals 3. This times 3/4 equals 3. And solve, and we get A equals 4. So the value of this term here would be 4. A little tricky there because you see fractions and you expect a fraction here, but this times that fraction is 3. Page 2. Part 5. This looks like some Pascal's triangle stuff. Please find the first 3 terms in the expansion of. So yeah, you could multiply that all out and it would take like 10 years, or you could write out Pascal's triangle down to the 15th row and it would take quite some time, or we could use what we know about the binomial expansion. So the exponent above this will start at 15, exponent above this will start at 0. Notice how I've included the negative there, and then these binomial coefficients are just like what we used when we were using combinations and permutations. So it's like the combination formula. So we start at 0. Remember, these numbers will always be the same. 1 and 1, 2 and 2. And the exponents will always add to 15. Exponents always add to 15, and exponents always add to 15 because that's our exponent. Okay. So 15 factorial, 0 factorial, 15 minus 0 factorial. Doing this will give you 1, doing this will give you 15, doing this will give you 105. And you don't need to, so I'll work, this one is trickier. I'll work this one out over here, just because some students were confused, like, hey, how on earth am I going to do that without a calculator? So 15 factorial is 15 times 14 times 13 times 12, etc., etc., etc. 2 factorial is 2 times 1. And this, 15 minus 2 is 13, so I could say that's 13 factorial is 13 times 12 times 11 times da 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 da. So the 11s cancel and the 12s cancel and the 13s cancel. And this simplifies to 15 times 14 over 2, which is like 15 times 7. And that you can do in your head, 70 plus 35, 105. So that's where that came from. You definitely can write this out and simplify and get perfectly reasonable numbers to multiply. So we simplify down. Don't forget, so let's see, this, oh right, okay, up here. So don't forget that you have this negative being raised to some exponent, and that's going to affect the coefficient. So this right here, we end up with this negative because we have negative 2 to the first power. So when we simplify, we end up with x to the 15th, and then negative, or minus 30, x to the 14th y, and then this, we get the 105, and the 4 came from this negative 2 squared. So don't forget that if there's a coefficient, that gets the exponent as well, not just the y. So that's where the 4 came from. The 4 goes in here. 4 times 105, 420, x to the third, y squared. Okay. And, well, I'll leave it at that. Okay, next one. Common ratio in a geometric sequence is 3/2. And the 5th term is 1. Find the first 3 terms. So again, I have written out a bunch of spaces here. I'm a very visual person. So you know that common ratio is 3/2. So we don't know what this is. We don't know what any of these are, but we know that the 5th term is 1. So if we're starting with A, we can say, let's see, times r, times r, times r, times r. So there was only 4 of them. I know it's really easy. It's a common mistake to just see 5 lines and be like, r to the 5th. But I recommend that you think about how many times it's actually multiplied to get from here to here. Okay, so a times 3 halves, our common ratio to the fourth, equals 1. That's this times this times this times this times this in equation form. Solving for a, we'd get 2/3 to the fourth. So that would be 16/18. Alright, that's only our first term. So, alright, so I erased something, so I just sort of cut in the middle of whatever I was saying. But here we are where we have, we figured out the value of the first term, so 16/81 by saying a times r times r times r times r equals 1. So we know that this term has a value of 16/81. We could multiply by 3 halves, which would give us 48/162, and that simplifies to a 24/81. That's a 1 for the value of our second term. We would then multiply by 3 halves, and that would give us 72/162, which reduces to 4/9 as the value of our third term. We can multiply by 3 halves. Let's see, all we needed was the first 3, so that would be our answer. But our fourth term, just so we check, which is how I figured out that I made a mistake in that video that I just cut out, would be, I'm sorry, that's 12/18, which reduces to the 2/3 as our fourth term, and then we see that if we multiplied that by 3 halves, we would end up with 6/6, which is 1, so it works. Alright, so it asks for the value of the first 3 terms, so we would express these as our answer. 1, 2, 3. Very good.